In this video, I want to look at a couple of formulas that describe some properties of a line segment. These are the midpoint and distance formulas. The midpoint of the line segment connecting 2 points, x1, y1, and x2, y2, I have a sketch here so you can visualize what we're talking about, is given by this formula. x1 plus x2 over 2 is the x value of the midpoint. y1 plus y2 over 2 is the y value of the midpoint. These are simply an average. You're averaging the x values and averaging the y values. So when we're finding a midpoint, we're giving the point that's exactly in the middle of these two initial points. Second, the length of the line segment, what we're measuring here is the distance between 2 points, x1, y1, and x2, y2, is given by this formula. This derives from the Pythagorean theorem, a squared plus b squared equals c squared. I'm not going to show it here, but you could envision a triangle in this picture and then apply the Pythagorean theorem and you'll get the distance formula. So what we're measuring with the distance formula, again, is the length of this line segment from the first point to the second point. The midpoint formula results in a point. It gives you another point. The distance formula results in a measurement, in a number. So that's a single value that measures the length. Let's look at an example. So let's find the midpoint and length of the line segment connecting -3, 2 and 2, -5. Here are those points sketched on a graph. So we're looking for the midpoint that's exactly in between the two of them, somewhere in here. Let's find that midpoint using the midpoint formula. x1 plus x2 over 2, comma y1 plus y2 over 2. Now, I can name either point x1, y1, and x2, y2. It really doesn't matter as long as I'm consistent. So let's say this is x1, y1, and this is x2, y2. x1 plus x2 is -3 plus 2. So take the x values and average them. That means you add them and divide by 2. And do the same with the y values. Take the y values, 2 plus -5, you add them, you divide by 2. That's an average. What do we get? So -3 plus 2 is -1. So this results in -1/2. 2 plus -5 is -3. So our result here is -3/2. So the midpoint between these two must be -1/2, -3/2. That's about right here on the graph, and that seems to line up with the picture that we sketched. That looks like it's about at the midpoint. Second, let's find the length of this line segment, or the distance between the 2 points, x1, y1 and x2, y2. So using our distance formula, d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And again, it doesn't matter because you're subtracting these values and then squaring the difference. It doesn't matter what order you apply the distance formula in. And so I can actually subtract the x values in any order, subtract the y values in any order, and it will still work out in the distance formula. I'm going to stay consistent with my first designation that this is x1, y1, and this is x2, y2. So we'll say 2 minus -3 squared plus -5 minus 2 squared. What does that give us? Let's simplify inside the parentheses. 2 minus -3 is 5. So we have 5 squared. -5 minus 2 is -7. -7 squared. That results in the square root of 25 plus 49. Remember, I can't just take the square root of each of these. I have to keep simplifying within the radicals. So 25 plus 49 is 74. I get the square root of 74. Now that's not a perfect square. That's an irrational number, and we're just going to leave it in this format You could also find a decimal approximation if you prefer that. But whatever this number represents, square root of 74, that's the length of this line segment. That's the measurement of the distance from here to here.